Okay, so John is going to line up 4 golf trophies on a shelf in his room. How many different possible arrangements can he make? Well, if you think about it, we can think of these 4 trophies as trophies, let's say A, B, C, and D, and they're on a shelf. And the way we can count the number of arrangements is through permutations, right? Because each order is different. So if you have A, B, C, D, or B, A, C, D, those would be different. And in fact, the permutations are easily counted because if you imagine 4 slots on the shelf, right, what can happen? Well, the first time we have 4 different trophies or letters to choose from. But once a letter is chosen, right, it can't be chosen again because whatever letter you pick here, A, B, C, or D, right, A, B, C, or D, whichever one's chosen, you can't also put it in the second, third, or fourth slot. So if you put it here in the first slot, let's say we put A here, right, it can't be used in the second slot here. So that means that if A goes in the first slot, then only B, C, or D can go in the second slot. So if there are 4 options to begin with, then there are 3 left. Right? Now, again, you have to pick one of them, one of these 3 here, B, C, or D. Let's say you pick B. Well, then this next time there will only be C and D remaining for the third slot, so there'll be 2 choices. And then there'll be only 1 choice left, whatever it ends up being, which is 1D in this case. But altogether, if you want to count the number of ways to arrange these, you multiply these numbers. 4 times 3 times 2 times 1, which is 4 factorial, and that's 24 here. Now, you could list all these out to figure this out, but using factorial will save you a tremendous amount of time. For example, if there was 5 different ways, right, to set this up, then you have to do 5 times 4 times 3 times 2 times 1, which is 120. You can imagine factorial gets very large. You can set this up on the graphing calculator quite quickly. 4 factorial is easy to calculate. You press 4, the math button, and then the factorial symbol is over here under probability. It's the 4th choice. Press enter and you get it. You don't want to have to do factorial by hand or list them out for larger numbers. For example, 9 factorial, press 9, math, and then scroll to probability, pick the 4th option. This number is 362,880. So factorial numbers grow very large. If you're not entirely convinced that this is true, try setting up a tree diagram here. And in a tree diagram, you'll realize there are 24 options in this case. So in the first arrangement, or first slot, you can pick A, B, C, or D. And I'll just expand A here. If you picked A first, then you can have B, C, or D. Those are those 3 options. If you picked A and B, then what's left? Well, you can have C or D. And then you would finish with D or C. Here, if you had picked A then C, you can go with B next, or D. If you had picked A, then C, then B, what's left is D. If you picked A, C, D, what's left is B. If you had picked A and D, then you can get B or C next. And then you could finish with D, right? Or what? Well, oops, not D, sorry. Oops. C or B. So what does that mean? Well, this means that if we start with A, there would be 1, 2, 3, 4, 5, 6 options, or 6 different arrangements for A. Now, if you had started with B, there would be another 6. So 6 and 6 is 12. For C, there would be another 6. You can keep drawing these out. And D, there would be another 6. We have 6 times 4, or 24 arrangements. So if you're not entirely convinced on how to permutate or arrange your data, you can set up a tree diagram. Other things you might see the notation 4P4. This means the same thing as P4, choose 4. So you have 4 items and 4 spots, and you're picking them and permutating them. There are different ways to arrange it. You might see P4, comma 4, where the first number stands for the number of items you have, the second number stands for the spots you have. Here we have 4 trophies and 4 ways to arrange, and 4 slots to arrange them in. That's what each of these setups mean. Here, permutations of 4 items in 4 available slots, and then again, 4 items in 4 available slots. This can also be done in the calculator. You would enter in 4, go to math, probability, and NPR, right? N for number of items, R for slots to arrange them in, second choice, and 4, this means 4P4, enter, and you get 24. And we'll get into other problems later that involve this. Okay. The faces of a cube are numbered from 1 through 6. The cube is tossed once. What is the probability that a prime number, or a number divisible by 2, is obtained? So if you roll a cube once, you can only get a 1, a 2, 3, 4, 5, or 6. Well, 5 is prime, right? Because it's only divisible by 5 and 1 evenly. That's a prime number. A prime number has two factors, 1 and itself. 3 is also prime, 1 and 3. 2 is the only even prime number. 1 is not prime. 1 is the identity. So it's just an odd number, right? This is an odd identity. And there are other wonderful properties of 1, but we're not getting into that right here. It's just odd and the identity for multiplication. I should write the multiplicative identity, but I think you get the point. Right? Multiplying with 1 doesn't change your value, so it's called the identity. I lost track of what I was doing. Okay, so divisible by 2 or prime. So we have 3 primes, and 4 and 6 are both divisible by 2, right? 4 divided by 2 is 2. And divisible by 2 just means when you divide by 2, you don't have any remainder. So that means these 5 are either prime, right? 5 out of 6 are prime or divisible by 2. So it's choice 2. Okay, we're spinning 2 spinners, and you get to spin each once. Brianna uses the first spinner to determine how many spaces to move, 1, 2, 3, or 4. Uses the second spinner to determine whether her move from the first spinner will go forward or backward. So find the probability that she will move fewer than 4 spaces and backwards. So let's consider all the different ways this could happen, right? Fewer than 4 spaces. So what's the probability she would move 1 space? Well, that's 1 out of 4. And she would have to spin backwards, 1/2. We multiply here when we have 2 events in a row. These are independent events, and independent events are 2 events that are connected to the same trial or round that don't affect each other. Whenever you have that, one thing and another, you multiply them. Because, right, you spin each spinner, those are connected in one trial. So this 1/4 and this 1/2 are all part of, let's say, one turn in the game. So you multiply those turns together. Now you add separate ways to win that are called mutually exclusive. In other words, if you spin a 1 and move backwards, that's one thing that could happen. Or you could spin a 2, that's fewer than 4, but you can't spin a 1 and a 2 at the same time. It's got to be one or the other. So these are exclusive. We add them. So now it's 1/4 to get a 2, and then you'd have to get a 1/2 of a chance. You'd have 1/2 of a chance of moving backwards. And finally, the final way you could play the game is by, sorry, not getting a 4, but by getting a 3, which is also fewer than 4. So it's plus 1/4 of a chance of getting a 3 times 1/2. And this would be the total probability. So it's an eighth plus an eighth plus an eighth, it's 3/8, right? That's your probability. Okay, spinners divide into 8 pieces. What event is most likely? So here we have how many pieces? We have 1, 2, 3, 4, 5, 6, 7, 8. And how many yellow? So yellow, there's 1, 2, 3. 3 out of 8. How many white? 1, 2 out of 8, so 1/4 or 25%. How many black? 1 black, so it's 1 out of 8. And green, 2 out of 8, right? Yellow, we did that already, 1, 2, 3 out of 8. Okay, so most likely, well, I'm going to order these. Yellow is the most likely, followed by W, which also is equal in probability to G. It's my own notation here. And the least likely is black. Okay. Which event is most likely to occur in one spin? The arrow will end in a green or a white area. Well, green is 2/8 or 1/4. So you have a 1/4 of a chance of getting there. Or, keywords or here, plus, right? So it can't land in green and another color, right? It's got to land in green in one trial, or white could happen. So white is 2 out of 8 as well. It's 1/4 and 1/4 or 1/2. The arrow end in a green or a black. So green, 1/4 plus 1/8. A fourth is 2/8. Oops. So that's 3/8, which is less than a half, because 4/8 is a half. Yellow or black. So 3/8 plus 1/8, which is also a half. So far, you can tell the answer has to be 4, right? These two are equal, so neither of them are more likely than the other, and this one's less. But anyway, yellow or green? Well, yellow is 3/8, and a green is 2/8. It's 5/8. All right, so that's the most likely. Choice 4. Okay. The bowling team must choose a president, vice president, and secretary. So you have 3 people to choose. If the team has 10 members, which expression could be used to determine the number of ways the officers could be chosen? Well, think about it. There's these 3 slots that are vacant, and there's 10 people to pick. One of the 10 people can go in the first spot, but then once one of those people are taken, there are only 9 left, and then only 8 left. So you can just multiply these 3. So it's 10 times 9 times 8. So it's 90 times 80. There are 720 ways to do this. But what's the expression here that fits this? Well, these are permutations. And the first numbers in a permutation always represent the amount of people or things you're choosing from. It's usually referred to as n, or the n choices. Permutated are ways. In other words, how many slots are there? In this case, there are 3, so it's n and p and r. And what this really ends up equaling is, right, it's a factorial situation where we have 10 factorial, 10 times 9 times 8 times 7 times 6, but then it's over 10 minus 3 factorial. And this looks really nasty, but all this is saying is 10 factorial over 7 factorial. And this is a wonderful situation to be in, because when you're trying to calculate this, 10 factorial means 10 times 9 times 8 times 7 factorial and so forth. 7 factorial, or 7 times 6 times 5. But 7 factorial will cancel out. So this really only equals 10 times 9 times 8, which is what we're saying over here. So with permutations, right, permutations are the expression you'll use when the order matters. And the order matters here because the slot you get chosen in is the rank you have in the council. So if you're chosen for president or vice president, that's very different. So permutations, order matters. But anyway, you can always tell what permutation to use by having the first number represent the total amount of things you're sorting out, and the second number representing the slots they're being sorted into. So in this case, it's choice 3. If you had to find 10p3 in a calculator, enter 10, math, scroll to probability, choice 2. So it's 10 and then 3. And you see it's 720. Okay. Local ice cream stand offers 3 flavors: vanilla, chocolate, and strawberry. 2 types of cone: sugar and wafer. And 3 toppings: sprinkles and nuts and cookie crumbs. White cookie. Okay, if Dawn does not order vanilla, so vanilla's gone, how many different choices can she make that have 1 flavor of ice cream, 1 type of cone, and 1 topping? Well, this is great because you just multiply. It's 2 flavors times 2 types of cones times 3 types of toppings. That's 4 times 3 or 12. The basic idea is, if you think of a tree diagram, you could have chocolate or strawberry. If you pick chocolate, you could have a sugar or a wafer cone, and then you have 3 toppings: 1, 2, 3. 1, 2, 3. And then, so this just means if you pick chocolate, you can pick sugar cone with sprinkles, nuts, or cookies, or you can pick chocolate with a wafer cone and sprinkles, nuts, or cookies. That's 6 choices already, and there would be another 6 here if you had started with strawberry. So these tree diagrams can help you count these types of situations. Okay, what is the probability of not getting red if these are divided to 8 equal regions? Well, red accounts for 1, 2, 3 of the 8, so it's 5 out of 8, the remaining. Faces of a cube are numbered 1 through 6. Cube is rolled once. What is least likely? Rolling an odd number. Well, 1 and 3 and 5 are all odd, so there's a 1/2 chance of an odd. So the probability of getting an odd, or like this, equals 1/2. Even, 2, 4, and 6, probability of getting an even is also 1/2. Rolling a number less than 6, well, it's 5 out of 6. Rolling a number greater than 4, that's 2 out of 6, or 1/3. So that's the least likely of all, right? You can only get a 5 or a 6. Keisha's playing a game, and okay, well, each spinner lands on, each time the spinner lands on orange, she wins. Okay, spins this wheel, what's the probability she'll win a prize on both spins? In other words, what's the probability she'll get an orange and then another orange? Well, these are independent events. If I spin an orange here the first time, it's not like I can't spin it again. And you might think the location of the arrow really affects. Like if I spun it and landed on orange, you might think, well, couldn't that possibly affect where it lands the second time? We're assuming these are independent. In other words, you're trying to randomly spin it or spin it as hard as you can. So there's a 1/8 chance of getting the orange the first time and the second time. These are independent events, one in a row. You multiply them. There's a 1/8 chance again. So you multiply these two. You don't want to add them because that would be like saying it's more likely, right? An eighth plus an eighth is a fourth, and it's not more likely that you get 2 oranges. That's harder to get than 1 orange. So here you get 1/64th, or an eighth squared. Okay. Draw a tree diagram showing all possible kids' meals. Okay. Well, here there are main courses, right? You can get a wrong color there. Tree diagrams start off, and what you're doing is you're just kind of showing all the different things that could happen. So first we can get main courses: hamburger, chicken nuggets, or turkey sandwich. And then you can get a side dish with that: French fries or applesauce. So F for French fries, A for applesauce. So far there are 6 possibilities, right? Hamburger, French fries, hamburger, applesauce. Chicken nuggets, French fries, chicken nuggets, applesauce. Turkey, French fries, and turkey, applesauce. And then last, there are 3 drinks. So you can get milk, right? Milk, juice, or soda. Milk, juice, or soda. You leave yourself more space, I hope. Milk, juice, or soda. Milk, juice, or soda, and so forth. Milk, juice, soda, and milk, juice, soda. So that's our tree diagram. And, if you wanted to count, just an easy way to do it is say, oh, this is 3 choices here. Each end branch represents more choices. There are 3 here. 3, sorry for this terrible diagram, and 3. So it's 1, 2, 3, 4, 5, 6 threes, or there are 18 choices. Okay. Students in a math class toss a 6-sided number cube or dice. The results are in the table below. What's the empirical probability of tossing a 4? Empirical is like experimental. In other words, based on these trials, what's the probability of tossing a 4? Well, how many trials were there? That's your denominator. There were 3 plus 6 is 9, plus 4 is 13, plus 6 is 19, plus 4 is 23, plus 7 is 30. So, tossing a 4 happens 6 times out of 30, right, which is choice number 2. Determine how many 3-letter ranges are possible with the letters A, N, G, L, E. If no letter may be repeated. So I think of this, right, as there are different locations to put the letters, 5 of them. At the beginning, there are 5 choices, 5 letters to pick. But then once you pick a letter, there are 4 possibilities to stem from there, then 3, then 2, then 1. Multiply all of these, 5 times 4 times 3 times 2 times 1, that's 5 factorial. The idea being that you could have A, N, G, L, E, right, or you could have A, N, L, E, G, A, N, L, G, E, A, N, right, let's see, get those all, A, N, G, E, L, and you just keep going. And what's going to happen is, as you do this, you'll find that there are 120 different ways to arrange this. Easy way to think about this, every situation is like this. If you're looking for the arrangements where it may not be repeated, if it was repeated, it would just be 5 times 5 times 5 times 5. But once you pick an A, right, if I pick an A here, I can't put it again here or here. There's only one A. So all you're doing here is permutating or multiplying. Factorial is incredibly useful, and you can do it on the calculator. So press 5, math, scroll over to probability, press 4, that's factorial. It can do it for you. Okay. Oops, sorry. Okay. Some books are laid on a desk. We have 2 English books. Okay. 3 math books. 1 French book, and 4 social studies. Okay, Sorry. Teresa selects an English book, and Isabel then selects a social studies book. Both girls take their selections to the library to read. If Truman then selects a book at random, what is the probability that he selects an English book? Okay, so if Teresa comes along and selects an English book, then there's only one English book left. Isabel selects a social studies book, so there's only 3 social studies books left. Okay, so they take their books away and don't return them. Truman then selects a book at random. What's the probability to get an English book? Well, there's one English book left out of 1 plus 3 is 4, plus 1 is 5, plus 3 is 8, or 1/8. So it's just a one trial experiment. Just count what you want to get, the 1 out of the total left, 8. Okay, probability that it will snow on Sunday is 3/5. Okay, so the probability for Sunday snow equals 3/5. Probability that it will snow both Sunday and Monday, okay, probability of Sunday and Monday is 3/10. What is the probability that it will snow on Monday, so snow on Monday, given it's snow on Sunday? So this line here is for given in probability notation on Sunday. Well, that just equals, and this is always true for conditional probability, the probability of both things happening divided by the given. So probability of snowing on Monday given Sunday. You can think of it as getting the probability of both out of, right, what is already given. And what's nice about these probabilities is that just remember that the second letter is given, and that's also the denominator, and the numerator is just the probability of both of them happening. And they'll probably give you those variables anyway. So here you're just dividing 3/10 over 3/5, right? Plug those probabilities in. Divide by a fraction, you multiply by the reciprocal. 3/10 times 5/3. And you can do 15 over 30 or half, or cancel. 5 over 10 is a half. And we have, 3 over 6 now. 3 over 2 times 3, or 3 over 6, which is 1/2, right? Choice 3. Sorry, I didn't really get too much into the why here. I explain on other videos. Just running out of time.